Hey everyone, welcome back. We're constantly bombarded these days with news about AI and incredible discoveries like the James Webb Telescope sending back those mind-blowing images from deep space, right?
It's like every day there's something new pushing the boundaries of what we thought was possible.
Exactly. And it definitely feels like technology is just leaping forward at an incredible pace. But, and this is what's got me thinking lately, is it all just how? Like, are we just getting better at building the thing, but maybe not necessarily understanding the fundamental why behind it all?
I see where you're going with this. It's like the difference between, say, building a faster airplane versus actually understanding the laws of physics that make flight possible in the first place.
Exactly. And that gets right to the heart of what we're diving into today, the work of Gregory Chaitin.
Now, there's a name that makes you sit up and pay attention. He's a bit of a legend, wouldn't you say?
Totally. This is a guy who was publishing groundbreaking math papers when he was like 15. So when Chaitin starts talking about whether scientific innovation is different today than it used to be, well, even the giants of science tend to listen.
And what's he saying?
Well, buckle up, because it's pretty provocative. Chaitin argues that science, at its most fundamental level, might actually be a bit stuck.
Stuck. That's a strong word. What does he mean by that?
So it's not that he's unimpressed by all the advancements we're seeing. He's not saying that building a faster rocket or a more powerful computer chip isn't impressive. But for Chaitin, it goes deeper than that.
Okay, I think I'm starting to get it. He's making a distinction between, let's call it applied science, the kind that gives us those tangible technological marvels, and what he calls fundamental science. Am I on the right track?
You got it. And to understand Chaitin's argument, we really need to unpack what he means by fundamental.
And it might be helpful to think about it this way. Imagine the last time you had this genuine aha moment where your understanding of something just completely shifted. Not just learning a new fact, but something more fundamental, like the rules of the game changing.
Okay, I like that. So it's not just about building the thing, but understanding the basic laws that even make the thing possible in the first place.
Right. Think back to, like, learning about gravity for the first time. Suddenly there's this invisible force governing the entire universe. Or the moment it clicked that everything around us is made up of these tiny atoms, each with their own strange little rules.
Okay, yeah, I get it. Those are the moments when the world suddenly feels simultaneously bigger and somehow more knowable.
Exactly. That's what Chaitin means by fundamental science, uncovering those bedrock principles that govern reality itself.
Okay, so how does this all tie back to Chaitin's argument that science is stuck?
So his claim is that we haven't had one of those true paradigm-shifting moments in science since, get this, the 1920s.
The 1920s. Whoa! That was the era of, like, quantum mechanics, relativity, stuff that completely revolutionized our view of, well, pretty much everything.
Exactly. Think about the sheer scale of those discoveries. They didn't just add to our existing understanding, they completely upended it. They were like, hey, the universe doesn't quite work the way you thought it did.
And Chaitin is saying we haven't had anything even close to that level of upheaval since then.
That's his point. He uses the example of dark matter. We've known about it for decades, this mysterious stuff that makes up most of the universe.
But we still have no idea what it actually is.
Exactly. It's like we've mastered the rules of a game without realizing there's a whole hidden level invisible to us.
And that's Chaitin's point. We're so busy building the next best telescope or particle collider that we've lost sight of these fundamental mysteries.
He's not denying that progress is being made. There have been incredible discoveries since the 1920s, for sure. But he sees them more as refining what we already know, not fundamentally changing our understanding of the universe.
So adding details to an existing picture versus discovering a whole new picture altogether. Is that what he's getting at?
Exactly. It's like the difference between inventing a brand new game with revolutionary rules versus spending years exploring all the strategies and nuances within those rules. Progress is definitely happening, but it's different.
Okay, that's a really interesting distinction. So where does this leave us? If Chaitin is right, and we're kind of stuck in a scientific rut, why might that be happening? What's changed? And get this, because this is where Chaitin gets really interesting going out. He points a finger at the world of academia itself.
Wait, really? You're saying the very institutions that are supposed to be the breeding grounds for breakthroughs might actually be part of the problem?
That's exactly what he's arguing. And to understand why, we need to dive into a concept he calls convivial solitism.
Convivial solitism. Okay, now you've got to explain that one. It sounds almost pleasant.
I know, right? It's almost an oxymoron. But it perfectly captures this weird tension that Chaitin sees at the heart of modern science. Think about it, the life of a researcher, a professor at the university.
Yeah.
They're surrounded by brilliant minds, constantly attending conferences and workshops.
Yeah, it seems like the epitome of collaboration, of intellectual cross-pollination, not exactly what comes to mind when you think of solitude.
Exactly. But Chaitin argues that beneath this surface of conviviality, there's intense pressure to carve out your own little niche, your specialized area of research. Because here's the thing, to survive in academia, you need funding, right?
And to get funding, you need to publish papers. And not just any papers, papers that are going to get cited, that are going to boost your impact factor. It's like this whole other game on top of actually doing the research.
The infamous publisher perish pressure cooker. It's like you're encouraged to be social, but only within the very narrow confines of what's considered hot in your field at that moment.
And so you end up with researchers, brilliant minds, but often they're not necessarily pursuing questions they're truly passionate about, but questions that will lead to the most publications, the most grants, the most recognition within that system.
So instead of following their curiosity wherever it might lead, they're incentivized to stick to well-trodden paths.
It's like the difference between exploring a vast, uncharted forest and being told to just walk back and forth along the same well-maintained trail.
And who loses out?
We do. Because those truly groundbreaking discoveries, the ones that make us rethink everything, those often come from the people who are brave enough to wander off the trail, who aren't afraid to ask questions that might seem crazy or irrelevant to others.
Chaitin actually tells this story about talking to Lenny Susskind, a brilliant physicist at Stanford. Apparently, Susskind was lamenting how many of his graduate students would come to him asking for research topics.
Isn't that wild? You'd think these bright young minds would be bursting with their own questions, eager to carve their own paths.
Right, but instead it's like they're asking for a map instead of wanting to explore the territory themselves. They're so used to being told what to study that they've lost that inherent drive to discover.
Which goes back to Chaitin's point. If we're constantly rewarding incremental progress within existing frameworks, how are those truly revolutionary ideas ever going to emerge?
He's basically saying we've traded in our philosophers' caps for hard hats.
Yeah.
We've become incredible builders, but maybe we've lost sight of those fundamental questions about the nature of reality itself. It's like expecting someone to invent a brand new color while only giving them a limited palette of existing shades to work with. Okay, so we've got this system that might be inadvertently stifling creativity. But surely there are people who've managed to break free, to make those big breakthroughs, even within the constraints of academia, right? So it's not all doom and gloom then, like we're not all destined to become, intellectual Romans, meticulously maintaining the scientific aqueducts without ever stopping to ask, hey, what exactly is water anyway?
Not necessarily. Chaitin actually highlights some pretty inspiring examples of how genuine breakthroughs can still occur, even if it often means, going against the grain a bit. Maybe even operating outside the traditional system altogether.
Okay, now you're talking. Give me some hope here.
Right.
Who are these scientific rebels, these champions of curiosity?
Well, one name that comes up is Stephen Wolfram.
Wolfram, as in Mathematica Wolfram.
The one and only. The guy who created the software that's basically like a superpower for mathematicians and scientists.
Okay, yeah, I've heard of Mathematica.
Yeah.
But what's that got to do with breaking free from the system?
Well, here's the thing. Wolfram didn't just create this incredibly successful software company for the sake of it. He essentially built his own scientific playground.
Wait, hold up. He created a company to fund his own WN research.
You got it. He built the tools he needed, powerful software for incredibly complex calculations, and basically freed himself from the constraints of academia. No need to chase grants, no pressure to publish in specific journals. He could pursue whatever questions fascinated him.
I gotta admit, there's a part of me that's a little envious. Imagine having the resources to just dive into any scientific rabbit hole that catches your eye.
And it really highlights something important. Groundbreaking work doesn't always require these massive institutions, huge labs, or teams of researchers. Sometimes it's about individual passion, dedication, and the freedom to follow your curiosity wherever it leads.
It's like that saying, necessity is the mother of invention. Maybe sometimes constraints can actually stifle innovation instead of fostering it.
That's a really interesting point. And Wolfram's not alone. Think about Andrew Wiles, the mathematician who finally cracked Fermat's last theorem.
Oh, wow, yeah, that was huge.
Okay.
Wasn't that the math problem that had baffled mathematicians for centuries?
Exactly. And Wiles basically spent almost a decade working in his attic, chipping away at this legendary problem. Talk about dedication.
Working in his attic, there's something kind of romantic about that image. This solitary pursuit of knowledge, driven purely by the desire to solve the puzzle.
And then there's this anecdote about Sidney Brenner, the Nobel laureate, who essentially took over for Francis Crick at Cambridge.
Okay, yeah, I know. Crick DNA, double helix, the whole deal.
Right. So Chaitin recalls Brenner saying that none of his Nobel Prize-winning friends could have accomplished their work in today's research environment. Makes you think, doesn't it?
It does. How we created a system that's so focused on metrics, on short-term outputs, that we've lost sight of the value of that long-term, curiosity-driven exploration. The kind that leads to those true aha moments that change our understanding of the world.
Which brings us back to Chaitin's belief that science was maybe at its most innovative when it was treated more like a passionate hobby, driven by pure, unadulterated curiosity.
Okay, so how do we recapture that spirit? We can't all quit our jobs and build software companies or hole up in our attics for a decade. How do we cultivate that playful, exploratory mindset within a world of, structured research, deadlines, and funding pressures?
It's a challenge, for sure. Maybe it starts by recognizing and valuing different paths, different timelines, different ways of measuring success even. Perhaps we need to create more space for risk-taking, for embracing uncertainty, for allowing researchers to truly follow their curiosity wherever it might lead.
It's like we need to re-inject a bit of that high school spirit into the world of professional science. Remember those days when you were just starting to grapple with big ideas, when everything felt new and exciting?
It's about fostering that lifelong learner mentality, that sense of wonder and possibility that often gets, pushed aside in the pursuit of specialization and achievement.
It's about remembering that sometimes the most groundbreaking discoveries come from asking, what if? Not from checking off boxes on a grant proposal.
Exactly. And who knows, maybe that shift in mindset, that renewed emphasis on curiosity and exploration might just be what sparks the next scientific revolution.
So on that note of hopeful curiosity, it sounds like we're due for a good scientific shakeup, right? How do we get things unstuck?
Well, that's the million-dollar question, isn't it? If it were easy, we'd be swimming in Nobel Prizes already.
Right. But we've been talking about this tension, this idea that maybe the very structures designed to nurture science, academia, funding models, all that might be inadvertently holding it back.
And maybe it's not even intentional. It's like, think about a garden. You need some structure, right? Trellises for the vines to climb, maybe some strategically placed shade.
Okay, I like that analogy.
But if you're too rigid about it, if you try to force every plant to conform to your predetermined design,
You end up with a pretty boring garden.
exactly. And maybe that's what's happening in science right now. We're so focused on metrics, on grants, on publishing in the right journals.
That we've lost sight of the wild, untamed curiosity that often leads to those truly groundbreaking discoveries.
It's like we've forgotten that science isn't just about having the right answers. It's about having the courage to ask the really interesting questions in the first place.
And even more than that, it's about being okay with not knowing the answer right away. Being willing to sit with uncertainty, to follow a hunch, even if it leads to a dead end, or even better, to a completely unexpected breakthrough.
And I think that's where the idea of convivial solitism comes back in. It's not about isolating ourselves completely, but maybe about reclaiming some space for that individual pursuit of knowledge, that quiet, almost meditative process of just thinking deeply about a problem, letting your curiosity lead the way.
So it's less about dismantling the entire system and more about finding ways to make it a little more accommodating to those maverick thinkers, those folks who might not fit neatly into the existing boxes, but who bring something truly unique to the table.
It's about creating spaces where people feel empowered to take risks, to pursue those crazy ideas that everyone else dismisses. Because, let's be honest, sometimes the crazy ideas are the ones that end up changing the world.
Okay, so how do we actually do that? How do we cultivate that kind of environment? Because it can't just be about telling people to be more curious, right?
Right. It's about more than just words. It's about changing incentives, about recognizing and rewarding different kinds of contributions. And maybe, just maybe, it starts with each of us,
What do you mean?
I mean, tapping into that sense of wonder that we all had as kids, that urge to explore, to question, to see the world with fresh eyes. That's where true innovation comes from.
So it's not just about changing the system, it's about changing our own relationship with knowledge and discovery.
Exactly. It's about remembering that learning isn't something we just do in school or in the lab. It's a lifelong journey. And the more open and curious we are, the more likely we are to stumble upon those truly groundbreaking insights.
So to wrap things up, it sounds like the question of whether science is stuck isn't just a simple yes or no. It's more nuanced than that.
Absolutely. There's no denying the incredible progress we've made, especially on the technological front.
But at the same time, there's this nagging sense that maybe we've lost sight of something important along the way. That maybe, in our quest for answers, we've forgotten the power of asking those really big, audacious questions.
And maybe, just maybe, by rediscovering that sense of wonder, that playful, exploratory spirit, well, who knows what we might uncover.
It's a good thought to end on, isn't it? It reminds me of a quote by, of all people, the artist Pablo Picasso. Every child is an artist. The problem is how to remain an artist once we grow up.
Maybe the same could be said about scientists or about any of us, really.
There's a lot of wisdom in that, for sure.
So, to our listeners, we'd love to hear your thoughts on all of this. Do you agree that science needs a shakeup? Are we too focused on building the thing and not enough on understanding the why behind it? Head over to our website or find us on social media and let us know what you think.
And in the meantime, keep asking those big questions. Never stop exploring, never stop learning, and who knows, you might just stumble upon the next big breakthrough.
And we'll be here to dive deep into it with you. Until next time, everyone.